before I get too far in this build, I'd like to show you, or YouTube, what I've got so far. I've only got a couple of additions I'm thinking about adding. But basically what it is an automatic door lock, or not so much automatic, but a electronic door lock that can control my lights, or the control system can control the door lock, my lights, and I'm thinking about adding the ability to control my air conditioner as well, because I have a window unit, and I'm thinking about adding the ability to control the window AC. So what it is an Arduino that controls a servo that's directly interlocked with the locking mechanism, and it's originally a deadbolt, and it's all mounted onto this piece of plexiglass so that I can see the inside to make sure that it's locking and whatnot. And then on the other side I just have a doorknob, and basically what this is a doorknob like this. You can see this is not for deadbolts, but just for a regular door lock or doorknob with the key. What I've done is I've cut the middle bar right here out completely, and I'm only using the screws so that on the other side of the door there are no screw holes. Because if I were to do anything else, there would be screw holes or bolts that I would have to protect somehow, or someone could easily undo the bolts and just put a screwdriver in my door lock and just unlock my door that way. So that's how I keep it secure, just to say. And the lock has no function whatsoever anymore. Previously I have had the original piece of the deadbolt. So there was one side that simply you turn one way or you turn the other way, and that would lock or unlock. And the other side you'd stick key in and turn the key either way. And I actually originally had the servo interlocked with that mechanism, so I could use both at the same, or either one that I wanted to. So if I wanted to unlock the door with my key, I could. There was a little bit more resistance because I had to turn the servo as well. And then if I wanted to lock, I could just lock it, with the key as well. And then previously, also I had it controlled with a radio from an RC car. This is the radio I used previously. This is the transmitter, and I had the receiver mounted on there, and it was the same receiver from the RC car. And basically, whenever the Arduino sensed the voltage going to what would have been the motor going to one of the pins on the Arduino, when it sensed it at a certain voltage or a certain negative voltage, it would lock or unlock the door. And then I had where the servo for steering was for the RC car, I had that connected to something else, and that would control whether or not a solid state relay, which is currently in my switch right now, that would turn on and off. And previously I had let's get in a screwdriver. Previously I had the switch and the solid state relay working both at the same time, so I could switch it manually or with the solid state relay with the radio controller. The thing about that is anyone can grab one of those radio controllers because it's just 27, I think it's megahertz, I'm not sure, but it's just a standard RC car controller. You could get tons of them off of eBay, or you could even go to like a simple store and get one from a regular RC car, and then just unlock my door, which not to worry about in my house because no one's as technically inclined as I am, but that's just something if you're worried about, you have little kids in your house that also play with remote control cars, then you would have to worry because they could just unlock your door and troll you, so to speak. The problem with the solid state relay is, though, if you can see it, every once in a while it will flicker. The light in my room will flicker. And that's not a good thing. You don't want that in the middle of the night. Your light's just flickering just slightly. It'll drive you nuts. And what I've done to help this is there's sound, or there's noise, is what they call it, radio noise, that's affecting the Arduino. And there's probably a better way to fix this than to do what I'm going to do. But I plan on adding another relay, just another little simple reed relay that will turn off the connection between ground and ground, pretty much. So right now it is connected to a digital pin on the Arduino. Let me just sit down here a second. It's connected to a digital pin on the Arduino. The positive coming from the relay, the solid state relay, and the negative is connected to ground. It just makes a circuit whenever the digital pin goes to high. And there's a little resistor going between the ground and from the solid state relay and to the ground of the Arduino, and that does help a little bit with the noise, but at the same time, it still flickers. And the bigger the resistor you add, it does seem to help more. But there's a certain point where the 5 volts going from the Arduino to the solid state relay and then back through that resistor to ground, it doesn't activate the relay. So it helps to reduce the flicker, but at the same time it won't turn on. Sorry, just me rambling there for a second and not really showing you guys anything. So basically what this is, so what I have right now is just the relay going to the digital pin and ground, and I'm just gonna add a smaller reed relay in between ground and the ground of the solid state relay, and then that will act as a switch, and basically I can turn that switch on and off, and that will turn on and off the relay. And if there's no connection to ground for the relay, then it won't flicker. So that's how I plan. Hopefully that's how it works. At least that's how I plan on doing that relay. And then, so right now I'm planning on getting a Bluetooth module in the mail soon, and that will be connected to my Arduino, and then I'll be able to control the lights, the air conditioner whenever I get that set up, the lights, the door lock with the Bluetooth module, and I can just control it with my phone, but until then I wanted to build it so badly, but the Bluetooth module is taking like forever to come through the mail because I got it off Amazon. So I just had to put some push buttons, some tactile switches, and this is in case later on I don't want to just grab my phone every time I want to unlock my door to go to the bathroom. The red light indicates that the door is unlocked currently, and the red button, the red tactile switch, when you push it, it will lock the door. And sometimes you have to push on the door a little bit to get it to go all the way. I know it's a little bit of a bummer, but that's just how it is. And you can see the red lights turn off. You push it again, it will unlock the door. It has no problems unlocking the door. It's only when you're trying to lock the door that it sometimes has a little bit of an issue, and you can see, I don't know if you can barely see it, like how slightly it moves when I push it in. Yeah, I'll try and be steadier. Yeah, but there's a slight warpage on my door, or my door frame, that causes that. And then similarly, there's a button for the light. The reason I don't have an indicator light for that is because the light itself is the indicator. So if I push the button, I think I may have disconnected the wrong, or may have disconnected it from the wrong pin, or reconnected it to the wrong pin. That is. Yeah, I definitely have. I just need to. Oh, there it goes. Okay, so what I've done there is I just accidentally pulled out the 5 volt. I mean the the positive to the solid state relay from the digital pin, and I'll try again now. Let's see. I'll just probably not the best angle here. Let's try it again. Okay. And this is all mounted onto a piece of PVC. I mean, a piece of plexiglass, and the two screws. Or let me try it. And the two screws that are going through the plexiglass. There's one above the servo and one underneath the servo. It's kind of hard to see. They are going straight into the door handle. The door handle does help when you're trying to pull the door shut, or theoretically it will help pull the door shut while I'm locking the door with my phone. And it's all connected to that piece of plexiglass, which is screwed into there, and it was wobbling a little bit, like back and forth, because it's so long. Those two screws weren't really helping. Weren't keeping it steady so much. So I was thinking about adding a third one. Oh, excuse me. I was thinking about adding a third one, but then I thought, excuse me again. I just thought, why not put a little bit of hot glue? So I dabbed a little bit of hot glue, which you're definitely gonna need your parents' permission for that one. If someone else was where to build this, so that's there. You can probably not see it at all, but there's the dab of hot glue. And my door is dirty. Ugh, I don't know how it happened. So I guess I just have dirty hands when I'm coming in and out. So that's what I have currently. And this switch plate is just the switch plate from the last switch I had. I decided not to manually switch it on and off. I'd rather have the button right there and the solid state relay. Later, when it's fully finished, I'm hoping to have a PWM, a free PWM on my Arduino connected to this solid state relay, so the solid state relay can be possibly dimmable, which will dim the light. I don't recommend this for all lights, like LED lights. Some of them aren't so dimmable, and I know some fluorescent lights aren't dimmable. But I just so happen to have a dimmable fluorescent light, and I am planning on just turning this solid state relay on and off quick enough to, which is PWM basically, to dim the light. And I just cut a little notch in it so that way the wires aren't getting too squished. This is not the final switch plate. I'm just gonna have a regular standard blank switch plate. This one actually doesn't fit onto this because it's both and this doesn't quite fit onto this with both screws. It's actually supposed to be screwed into the mechanism, the switch itself, and then the switch is supposed to, well, not then, but the switch is just supposed to be screwed into the box, the electrical box that it's in. So, and then I have these two. Sometimes it's hard to see in here with the light. Let me just turn the light on. So here are these two wires that go straight up over the door. You can barely see it up here. It actually is like tucked behind the door frame a little bit. And then they come down, and then they slowly come to this door hinge, and they sometimes slip off, but I'm planning on putting a simple staple right here to prevent that. And actually, there's absolutely no strain on these wires. If you can see, like that's really loose right there, and these are really loose. And then it all goes to this, which is, I added a little knot, well, not so much knot, but just like a kind of a twist right here, because they're solid core wire. The little twist will help prevent strain from the door to the Arduino, which is actually, there's none anyway, so that's just an extra precaution. And then this is the power source. I have a power strip over here, which has been mounted onto my dresser. Kind of a messy dresser right now, but yeah, that's my dresser, and I have it connected to a 12 volts. Here, there's a similar one right next to it. I might as well just unplug that one. This is a 12 volts, 1 amp power supply, It's kind of hard to see. But yeah, that's what that is. And then I just simply feed that to my Arduino. This servo goes over my closet door, and it goes over to my door to the outside, I guess. Not to outside, but to my living room. And then it just comes around with the other cord or wires. And I found that the servo needs actually quite a lot of amperage, and I've tried a 5-volt actually not 5. Yeah, it was 5 volts. I've tried a 5-volt 2-amp power supply, and the first thing with that is the Arduino only takes 6 to 20 volt or 24 volts. I'm not sure if it's 20 or 24, but yeah, the Arduino Uno only takes a minimum of 6 volts. That's because it has a 5-volt regulator on it, and the 5-volt regulator needs something above 5 volts to take it. So I had to do something kind of risky and actually attach it to the VN, or to the VN on the Arduino. I don't know why I'm so far away from the Arduino, but I had to connect it to the VN, and that was still not enough power for the servo to be fully like lockable. And I think it was just because of 5 volts 2 amps is not as much power as 12 volts 1 amp. Not at all. I haven't done the math or anything, but I'm just assuming that that's more power. And that goes straight into the not the 12 volts can go straight into the servo. That actually might help it a lot if instead of powering the servo off of Arduino, I powered the servo off of a separate supply and had the signal coming off of the servo that was actually connected to the servo control pin on the Arduino. I haven't tested this, but I don't see why it wouldn't work. And another thing I have is a door closer. It's just a simple spring and a rope, and the rope is screwed into the wall, or into the door frame, and then the spring is screwed into the door. And I have a little piece of felt up here to make sure it doesn't hit the door too hard. It does hit too hard if I pull the door all the way as far as the wall and then let go of it. Usually I have to at least be this close before it doesn't make too much noise. Anything more than that, you might be considered slamming the door or something like that. And let's see if I can find my hardware. Thank goodness it's on the top. My hardware bin right here has an extra spare spring, which is right here. I got these off of the lamps that are adjustable. They're really useful. Those lamps that you can just clamp to your desk, and then you can adjust them, and they stay in place with these springs. And it's a compression spring. It's not a I don't know what the other one is called, but it's a compression spring, not a spring that pushes. So it pulls the door closed instead of pushing the door open, I guess. And it's just connected to a string because I wanted it to be across the whole door. It's actually the same string and everything. This is actually a backup in case that one breaks or something, but it hasn't broken so far. It's a pretty rugged spring, which is pretty big too, which you need a big spring for this. You can't have a 2-inch or a 4-inch spring. You probably need something at least 6 inches or more, like this one. And this is paracord, not some wimpy string, but this is paracord that can handle up to I'd say 120 pounds. But obviously it's nothing that intense on the door. I'd say probably standard, when it's closed, it has a little bit of tension on it. Probably no more than 5. I wouldn't even say it's 5, maybe 3 pounds maximum. Pulling on the door while it's closed, and then, I don't know how much strength it would be pulling on the door when it's fully open. Probably a lot actually. The spring does not get fully sprung. That sounds bad, but fully pulled out. It gets pulled out maybe 75% of what it possibly can, I'd say, before damaging the spring, that is. And I'm rambling horribly at this point in time, and I'd like to say thank you, YouTube, and please keep watch for my next videos, even though I know this one's been forever in the making. I should have probably shown you guys more, not at this point in time, because I know I'm taking up so much of your time. I'm rambling so much at this point. One more thing before I leave you guys. The servo had to be spaced away from the door platform of plexiglass that I have. I just took some simple plastic rods and bolted it through there. I'm sorry, you guys. I'm taking up too much of your time. You probably didn't even watch all the video, so that's okay. I have 3 subscribers currently, and I doubt that they'll watch the entire video. Just say that anyone else will ever see the video. But thank you, and have a nice day, and leave me some comments, please. I guess. Thank you. Bye.